Hello, everyone, and welcome back. The topic is the asymptotes of a rational function. And so, in this lesson, we will discuss how to determine the vertical and horizontal asymptotes of a rational function. First up, what are rational functions? A rational function is a function of the form f of x equal p of x over q of x, where p of x and q of x are both functions of x. P of x can be a constant. A rational function may have what we call a horizontal asymptote, a vertical asymptote, or an asymptote which is linear or nonlinear. An asymptote is a line that a graph of a function approaches but never touches. And these are peculiar to rational functions. That is, they only appear in rational functions. And they are very, very important to study. Vertical asymptotes can be found by solving the denominator, so they are easily found. Horizontal asymptotes can be found by examining the terms with the highest powers in the numerator and the denominator. We will examine three different cases in this lesson. Our first case is where both our numerator and the denominator have the same term. So if the highest powered term in the numerator is the same as that of the denominator, then the horizontal asymptote is the ratio of their coefficients. Now, first, I want to look at this graph so we can talk about it a little bit and see exactly what's going on when we write x over x plus 1. Let us try to draw this graph. F of x is equal to x divided by x plus 1. Now here we have the graph of f of x is equal to x divided by x plus 1. Let's zoom out a little bit and have a better look at it. Now notice that for the denominator x plus 1, if we should solve this to get x plus 1 equals 0, then we get negative 1 here, and negative 1 would make this 0. Notice that the graph approaches negative 1 here, but it never touches it. Notice here as well, from this side, that the graph approaches negative 1, but it never touches it. And so this negative 1 here would be the vertical asymptote. Now, how about the horizontal asymptote? So the function can have both, or one, or several. So in this case now, look at this line. As the function, as x goes further negative, notice that the function is heading toward this line, 1. That's 1 on the y-axis, is heading toward it. And as the function raises here, notice that it's also heading towards 1 in this direction. So 1 here would be a horizontal asymptote for this function. So how do we find them without looking at the graph? Let's look at this example. Now, it's the same question that we just looked at a while ago. So to find the vertical asymptote, what we do is that we solve the denominator. So the vertical asymptote, what we say is that we turn the denominator x plus 1, set it equals 0, and we solve it, we get x is equal to minus 1. So if x is minus 1, then that number will blow up the denominator, it will make it 0. And because of that, we will not be able to compute a value there. So x equal 1 is the vertical asymptote. Now the horizontal asymptote, to find that, what we do is that we look at the function and we divide both our numerator and our denominator by the highest power that we have. So we have x divided by x plus 1, and what we do is that we divide both the numerator and denominator by x. So x over x, all of that over, we're dividing by x plus 1 over x. And what this gives us is 1 over 1 plus 1 over x. And as you can imagine, if x keeps getting bigger and bigger, then what's going to happen is that this term is going to get smaller and smaller. And so what we're going to have is that this 1 divided by 1, 1 over 1, it's going to end up being 1 over 1, which is 1. And so this is the horizontal asymptote. I'm going to write it as horizontal asymptote, and it's y equal 1. In this case, the vertical asymptote is to solve this. So solving this would give us x is equal to 5 over 2. That's a vertical asymptote. For the horizontal asymptote now, we would need to divide both the numerator and the denominator by x. So dividing 3x plus 1 over x and 2x minus 5, divide both of those by x. And what we end up with is 3 plus 1 over x and 2 at the bottom minus 5 over x. Both of these, 1 over x and minus 5 over x, eventually, if x gets bigger and bigger and bigger, are going to head towards 0. And so our horizontal asymptote is going to head towards 3 over 2. So it is the ratio of these two numbers, a over b, 3 over 2. And so our horizontal asymptote is going to be y equal, let me just write that a little better, y equal 3 over 2. All right, let's continue. The second case is where the denominator has a larger power than the numerator. So if our highest powered term in the numerator is less than that of the denominator, then the horizontal asymptote is the x-axis or the line y equals 0. So as long as the power in the denominator is bigger than the power in the numerator, and we're looking at the highest powers, the highest power in the denominator is bigger than that of the numerator, or the numerator is smaller than the denominator, then the x-axis is always going to be our asymptote, or horizontal asymptote. The vertical asymptote, remember, you find that by solving the denominator, letting it equal to 0 and solving it. Let's look at the graph for this one and see what it looks like. So we're going to be graphing 1 over x plus 1. So 1 divided by x plus 1, and we'll see what it looks like to get a better understanding of it. So here we go. Let's just zoom it out a little. So notice here that as the function heads toward this negative side, that the values are getting close towards this x-axis here, the 0 line. And as the function heads in this direction as well, notice that it's getting closer. As x gets bigger, that the function is heading closer and closer to 0 along this line, along the x-axis. And as x keeps getting further in this negative direction, the same thing is happening. So the situation is, as long as the power in our denominator is bigger than that of the numerator, then what is going to happen is that the horizontal asymptote is going to be the x-axis. The vertical asymptote we find by solving the denominator. Let's look at that. So if we have this case where we have f of x is equal to x plus 3 over x squared minus 1, then we can find our vertical asymptotes by letting our denominator, x squared minus 1, equals 0 and solving that. So we have x squared is equal to 1 and solving it. We get x is equal to, taking the square roots, x is equal to plus or minus 1. So we have x is equal to 1 and x is equal to negative 1. And these will become our vertical asymptotes. So this will have two vertical asymptotes. On the other side of it, to find the horizontal asymptotes then, what's going to happen is that we look at this and we realize that the power in the denominator is bigger than that of the numerator. So if we divide both sides by the larger power here, what we're going to have is x over x squared plus 3 over x squared. This is just a formality to do it. And x squared over x squared minus 1 over x squared. And this here leaves us with 1 over x plus 3 over x squared and over 1 minus 1 over x squared. And as you can see, As x gets larger, as x tends to positive infinity or negative infinity, it doesn't matter. What's going to happen is that this is going to keep getting smaller and smaller and smaller and smaller. And so we can see that from the graph that we looked at a while ago, that as x keeps getting bigger and bigger, then the graph keeps heading closer and closer towards zero. And so that is essentially what is going to happen here. This is going to head towards zero. This is going to head towards zero. This is going to head towards zero. It will not reach it, but it will continue heading toward it. And that is what the idea of an asymptote is. That is, it's a line on the graph, and they only happen in rational functions, where the graph will approach it, but it never reaches it. Later on, when we start doing calculus, or you start doing calculus, they will become the interesting things that we call limits. But for now, we're just talking about them as asymptotes and how to find them. Here's our third case, where if the highest powered term in the numerator is greater than that of the denominator, then the asymptote, and we're talking about horizontal asymptotes, the horizontal asymptote is either slant or is another function, but there will be no horizontal asymptotes in this case. So let's say that again. If our numerator has a higher power than the denominator, then this function will either have a slant asymptote or some other asymptote that's a function of x, but there will be no horizontal asymptotes. And let's try it out on this one and see. So we're going to draw our graph of this one and look at it and see what happens. So let's try to graph this. It's x squared minus 1. So x squared minus 1, let's just write that in. X squared. Okay, come on. All right, there we go. So x squared minus 1, and that is divided by x plus 3. X plus 3. Okay, so there we have it. Now there's our graph. And notice here, let's just zoom it out a little bit. Notice here that as the function approaches, as it gets bigger in this direction, as the numbers get bigger in this direction, notice what's happening, that this side of the graph is actually looking like a straight line. And it actually is a straight line, and we could actually work out the equation of this by dividing through this function. So again, we can find our vertical asymptotes by solving the denominator. Notice if we solve this denominator, we get x plus 3 equals 0, so we'd have minus 3. And notice here that this minus 3 is the vertical asymptote. So this function is going to head toward negative 3 in this direction, but it's never going to touch it. And in this direction, it's going to run along this line, this slant line. So our situation is that if the highest power in the numerator is greater than that of the denominator, then in this case, when it's just 1 degree higher, it's a slant line. If it's more than 1 degree higher, then it ends up being some other function. Now let's look at that without the graph. So here we have our function, and we can look at the vertical asymptote, which is easy. So the vertical asymptote, remember, we solve it by saying x plus 3 equals 0, and therefore x is equal to negative 3. And so notice here that the function will head towards negative 3, but never reach it. And the horizontal asymptote now, we need to divide. We can to find what the actual equation is. We can actually divide x squared minus 1, x squared minus 1 divided by x plus 3. You can use synthetic division to do this. It would work out pretty simple. So we'd have x squared plus 0x, since there's no x term. But since we started it with long division, let's just continue it. Plus 3 And so x into x squared gives us x, and x times x there is x squared. We subtract, and that's 3x. So we're subtracting 3x. So we have a minus 3x here, and then plus 3. X into minus 3x gives us a minus 3, and x times that minus 3 gives us minus 3x plus, minus 9. And subtracting this, we get 3 minus negative 9, which is 3 plus 9, which is 12. This is our remainder. And so the equation of the asymptote here, which is a slant asymptote, is actually x minus 3. So you can actually find it. But the idea here is just to show that if the power in the numerator is larger than that of the denominator, then there will be no horizontal asymptotes. So there's no horizontal asymptote. There is a slant asymptote, or it can be another function. And we can always find that by dividing it out if we want to find it. Not necessarily to find it, but if you want to find it, you can do that by dividing out and seeing what it is. So let's look at one more example. Here we have x to the third plus 1, and we're dividing that by x minus 2. Our vertical asymptote, again, simply is to just solve the denominator. X minus 2 equals 0, and that means x is equal to 2, which means that our vertical asymptote is 2. And so this function will approach 2, but not reach it. And our horizontal asymptote is, notice, we have x cubed plus 1 divided by x minus 2. And we could divide this out and find what the vertical, what the other asymptote is. It will not be horizontal. And it will not be horizontal because this power here is greater than this. And if we notice, if we divide x to the third by x, what we're going to get is x squared. So we're going to have some asymptote that's quadratic. And so that's how we approach these asymptotes. They're very important for later work in looking at limits. Right now, we're just looking at how to find them by looking at the graph and doing simple algebra in terms of solving our denominators to find the vertical asymptote and doing some simple division to see if we have, to see what horizontal asymptotes they are, or if there are any.